Okay, so can everyone hear me? Okay, so can everyone hear me? Hello, hello, yes, yes. Okay, so can everyone hear me? Hello, hello, yes, yes. Okay, so can everyone hear me? Hello, yes, yes. Okay, so can everyone hear me? Okay, so can everyone hear me? Hello. Yes, can you all hear me? Type yes if you can hear me. Okay, Sange. So you can you hear me now? Yes, type yes if you can hear me. Yes, okay. The audio is clear, right? Is the audio clear? Hello? Okay, so the audio is clear, but internet is weak. Okay, so let's wait for some more time for more people to come.
Shit.
Okay, so there are only 4 people right now. I think some more will come, so we'll just wait for 5 more minutes. Yeah, so okay, can we start now? Type yes if we can start now. And we can start soon. Yes, can we start now? Okay, so okay, so there are a total of 3 people in this classroom. Okay, no problem. So okay, 4 people now. So yes, we are going to start our class now, uh, and the class is based on atoms and molecules. Okay, so for the last time I'm asking you again, is your internet sorry, can you hear me? Yes, can you hear me, and is everything clear in the video? This can you read atoms and molecules and mole concept and everything? If yes, then type yes. Okay. I'm waiting. Yes, yes, okay. So let's start the chapter. So today we are going to learn about atoms and molecules. Okay. So this will totally be based uh, on how we are going to on the competitive exam NTSE. So we won't be looking much into the concepts right now. We will just be doing more questions. Okay. And the main topic in this chapter will be mole concept. Okay. It will be a mole concept. So here what we are going to study is that mole concept is really important. Okay, it came in 9th and then it will come in 11th as well, and it is like really important for NTSE class 11, class 12, NEET, JEE mains, advanced and everything. Okay, so let's move ahead. So first we are going to start our class. Okay, wait. Someone is having problem. I can only read mole concept. Yes. So in this slide we were talking on mole concept only. So now let's start our class with a question. The question is really simple. It is given here that calcium carbonates decomposes on heating to form carbon dioxide. When 10 gram of calcium carbonate is decomposed completely, then 5.6 gram of calcium oxide is formed. Calculate the mass of carbon dioxide formed. Okay, so I am giving you 30 seconds. In 30 seconds, please try to do the question. I am waiting. Okay, this is a really simple question. So calcium carbonate is given to us and it decomposes on heating. So to form calcium oxide and carbon dioxide. So the amount of calcium carbonate which is being decomposed is 10 gram and out of which 5.6 gram is calcium oxide. Now we need to find the mass of carbon dioxide formed. I am waiting for 30 seconds. Okay, can you repeat again? Okay, I think the video is not that clear, so I would recommend that you watch it in the highest resolution possible, which is I guess 480 pixels. So anyways, I am going to repeat again. Calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. When 10 grams of calcium carbonate is decomposed completely, then 5.6 gram of calcium oxide is formed. Calculate the mass of carbon dioxide formed. Okay, so let's say we have calcium carbonate. Okay, wait, let me just take this. Yes, so we have calcium carbonate, right? And we know that the formula of calcium carbonate is CaCO3. Okay, so this is the formula of the calcium carbonate. So now it decomposes, right? What does decompose mean? It means from one two substances are formed, right? So on heating to form calcium oxide and carbon dioxide. Okay, so here we will, let's just write calcium oxide, and another thing that is formed is carbon dioxide. Here I am not teaching you how to write chemical reactions. I am just teaching you in this in a pictorial form. Okay. So now it is given that the mass of calcium carbonate is 10 gram. Mass of calcium carbonate is 10 gram. Okay. And it is given that after burning the mass of calcium oxide is 5.6 gram. Okay, it's 5.6 gram. So now we have to find the mass of carbon dioxide. It's a really simple question, so I'll wait for you to answer. Okay, I'm waiting 10 more seconds for you to answer. I'm still waiting. Yes, Sangi, you are right. It's 4.4 gram. So this will be 4.4 gram. Okay. So this was a really easy question. And yes, Lippy, it is law of conservation of mass. So we are going to study the two laws of we are going to study the two laws of chemical conservation, out of which one is law of conservation of mass. And yes, all of your answers are correct. The correct answer is 4.4 gram. Okay. So let's see what does the law of chemical combination, the first law of chemical combination states. So the law of the law of conservation of mass was devised by Lavoisier in 1774. Okay. So not very important, but I am still writing it. 1774. So the law of conservation of mass was devised by whom? Lavoisier in 1774. And what it states is that basically the mass of reactants is equal to the mass of products. Here in the earlier question, our reactant was CaCO3 and our products were CaO and CO2. Okay. So this is the law of conservation of mass, and I am pretty sure all of you are familiar with it. This is a really easy topic. We are just going to brush through it. Okay. Let's go fast. So this is law of conservation of mass, and have you all understood this? Type yes if you have. I'll be waiting. If you have understood this, type yes. Yes, yes, okay. So you all have understood this, right? So let's move on. So we are just going to keep doing questions, okay? So when 3 gram of carbon is burnt in 8 grams of oxygen, okay? 3 gram of carbon is burnt in 8 grams of oxygen. 11 grams of carbon dioxide is produced, okay? Is what? Is produced. What mass of carbon dioxide will be formed when 3 grams of carbon is burnt in 50 grams of oxygen? So I am not sure if you all can see it, so I'll just high up the font size of the questions. Please wait. Yes, so yeah, please wait for just 1 minute, okay? Yes, let's just keep it like this, okay? Okay, so here you are. When 3 grams of carbon is burnt, 8 grams of in 8 grams of oxygen, 11 grams of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 grams of carbon is burnt in 50 grams of oxygen? Okay, So this is, I won't say it's a really tricky question. So if you know the both the law of combination, so you will be able to find it pretty easily. Okay, so actually not even 10 seconds are required for this question. So let's say carbon plus oxygen. Okay, carbon is burnt in oxygen to form carbon dioxide. Okay, now it is said that in the first case, okay, this is the first case. So in the first case, carbon is burnt. When carbon is burnt, 3 gram of carbon is used and 8 grams of oxygen is used. Okay, so following the law of conservation of mass, obviously we will get 11 grams of carbon dioxide. There is no other reactant present here, right? There is no plus, no reactant. Okay, so Sneha is saying 53 gram. Let's see if she is correct or not. So in the next we have in the second case, okay, C plus O2. My handwriting resembles my real life handwriting, sorry for that. So it's CO2 again. Now in the second case, the interesting thing is that 3 grams of carbon is used, but 50 grams of oxygen is used. Okay, so 3 grams of carbon and 50 grams of oxygen. 50 grams. Okay, sorry for that. 50 grams of oxygen is used. Okay, so now we have to find what mass of carbon dioxide will be burnt. Okay, so now I have gotten two answers, 53 gram and 99 gram. Okay, and sorry to say, but both of them are wrong. So let me just explain it to you how we can do this. Okay, so if you all remember the second law of chemical combination, it was devised by Protus, and it stated that a chemical compound always consists of the same elements combined together in the same proportion by mass. Okay, so what it states that in a chemical reaction, the proportion in which two reactants can be two reactants can be reacted cannot be changed. Okay, so if this is 3 gram and this is 8 gram, so the what we can call the proportion of reaction of mass of C and O2 is 3:8. Okay, so this ratio cannot change. Okay, you keep in mind this ratio cannot change. So if let's say in the second question, in the second case it was written that 6 grams of carbon is used. If 6 gram of carbon was used, then 16 gram of oxygen would be used. Now here it is 3 gram, and Sange, you are absolutely right, it's 11 grams. So let's just see it, I'll explain it to you. So when 3 grams of carbon is used, ratio cannot change, right? So 8 will remain 8. So out of 50 grams, 8 grams will be used. Okay, so 3 grams and 8 grams will be used. What will happen to the other? It will become another reactant, another product. So it will be O2. So let me just write it not so messily. So let's say C plus O2, CO2 plus O2. Now there is 3 grams of carbon, as we know cannot be break, so it will 50 grams, and we will just get 11 grams of carbon dioxide, and the other 42 grams will be oxygen residue. Okay, so has everyone understood this? The answer is 11 grams. Okay, the answer is 11 grams. Everyone got it right? Fine. So we'll move ahead again. So next again question, we are just going to keep doing questions. Okay, a 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 of boron, gram of boron, and okay, Sneha, you don't get it, we'll get back to it again. Okay, we'll get back to it again. Let's just do this question for now. After this question I'll just explain it to you again. Okay, so contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by mass. Okay, so percentage composition of the compound by mass, you don't need to get scared of it. Okay, let's just draw a line. So the compound, the mass of the compound is 0.24 gram. Okay, so I'm just writing in short form because it's really hard to write with the mouse. So mass of compound is equal to 0.24 gram. Okay, listen to my words more than my writing. 0.24 gram, and we have found that the mass of boron was how much? 0.096 gram. Okay, 0.096 gram, and the mass of oxygen is 0.144 gram. Okay, so let's see if you can do it. Okay, so I'll just wait for 30 seconds and I'll wait for the answer. Let's see, try it. There are two answers. Okay, one for boron and one for oxygen. I need both of those. 144 gram. Yes, it's a nightmare to write with this mouse. Okay, I'm waiting. Okay, so there is actually a time lag between what I'm speaking right now and what you're watching. Obviously there will be a time lag, so I might take a little bit longer to respond to you. Okay, so yes, I won't wait for your answer. I guess you, by the time you hear this, you might have done it. So let's just erase all of it and we'll do it again. Okay, so we have 0.24 gram of compound, out of which 0.096 gram is boron and 0 of oxygen. Okay, so now percentage composition of the compound by mass, what is it? Okay, so let's just ignore this percentage for now. Okay, let's just ignore it. Yes, Archisha, you are right. Okay, I saw your comment just now. You are right. So the composition of the compound by mass. Okay, so what it is? So let's say it is the ratio of the mass of one of the product and the whole reactant. Okay, so what it is mass of compound by mass of boron. For now let's take boron. Okay, so this is for boron into 100 because it is percentage, right? Now let's take into consideration the percentage part. So it is mass of one of the reactants divided by mass of the product into 100. So now we know mass of boron is how much is mass of boron here given? 0.096 divided by 0.24 into 100. So I am not going to do the calculation, but the answer should be boron 40%. Okay, so boron should be 40%. Now there we can see how many reactants are there. There are only two reactants. So if one of the reactants is 40%, the other obviously will be 60%, right? So the other is 60%. So let's see the answer. Yes, percentage of boron 40%, percentage of oxygen 60%. Okay. So yes, Archisha, you are right. Sneha, you are right. Okay. So we'll do the previous question once again because Sneha didn't understand it. And if you have any problem in this question, you can comment that too. I'll explain it once again. If okay, so you don't need to hide the answer now. Okay, so yes, so Sneha, see, everyone see. So the second law of combination states that the proportion in which products react cannot be changed. Okay, so if we know that 3 grams of carbon reacts with 11 grams of, oh sorry, not 11, 3 grams of carbon react with 8 grams of oxygen, okay, 8 grams of oxygen. So then what we get, CO2, it will be 11. Okay. So now the second law of chemical combination states that ratios cannot be changed. So now you cannot just take 6 grams of carbon and try to combine it with 8 grams of oxygen. It won't work. It will be, CO2 will remain 11 grams, but we will get residue of how much? There are 3 extra grams, right? So 3 grams of carbon is used, 8 grams of O2 is used, but here we get CO2 how much? 11 grams. So how many grams are left? 3 grams, right? 3 grams are left. So that 3 grams will be residue. C will be 3 grams residue. Okay. So let's explain this in respect to this question. So yes. So 3 grams of carbon is burned in 8 grams of oxygen. 3 grams of carbon is burnt in 8 grams of oxygen, O2, to form 11 grams of carbon dioxide. Now since we know this, let's keep in mind the ratio is 3:8. Okay, the ratio is 3:8. Let's not forget this. The ratio will keep combining in this ratio. Okay. So for your easier understanding, I'm also going to give another example, but let's just wait. Let's just complete this. So now we have 3 grams of carbon, same amount of carbon. So now that we have 3 grams of carbon, can we take a larger amount of oxygen and combine? No, right? So here it will be, it will combine, there are 50 grams of oxygen, but only 8 gram is going to combine. Only 8 gram of oxygen is going to combine. Sorry for my bad handwriting. Okay, so only 8 grams of oxygen is going to combine, and the rest of it will be residue. Okay, so 42 grams will be residue, 42 grams of O2. Okay, now we know 3 grams of carbon and 8 grams of O2 forms 11 grams of CO2. Okay, it forms 11 grams of CO2. Okay, so now plus 42 grams of O2 is already left with us, right, as a residue. So it will be plus 42 grams of O2 as residue. Okay, so here they asked us what mass of carbon dioxide will be formed, which is 11 grams. So the answer is 11 gram. I hope all of you have understood that we are lagging behind in class, so we'll just move forward. And if you have understood that, type yes, and if you have understood this question, type yes. Okay, so let's move on. The second law of chemical combination, I hope you have understood it by now. It is law of constant proportion, which was proposed by Proust in 1779. Okay, 1779 it was proposed by Proust. It states that a chemical compound always consists of the same elements combined together in the same proportion by mass. Okay, so the proportion of hydrogen and chlorine in HCl cannot be changed. Okay, I am just giving you an example. So yes, this is it. If you want to screenshot it, you can. It's not very necessary. So let's move faster. Okay, so the next question, this is a really easy question. I hope I don't have to give you the answer. Calculate the formula mass of potassium carbonate. Okay, potassium carbonate, okay, wait, potassium carbonate K2CO3. Okay, now they have already given the atomic mass of everything. We just need to find the formula mass. Okay, so fire on, do this quickly. I'll keep waiting. No, I won't keep waiting. Wait. So let's say the formula is K2CO3. Okay, K2CO3. So what does it mean? There are 2 moles of moles. If you remember correctly, then that's great. If you don't, then I'm going to explain it. Okay, so let's just say mole is something. Mole, there are 2 moles of there are 2 moles of potassium. There is 1 mole of carbon, 1 mole of oxygen. Okay, K2CO3. Okay, so now what will be the formula mass? Formula mass is what? In grams. Okay, formula mass is denoted in grams, not in U. So we have to change atomic mass to 39 gram. Okay, everything can be changed like that. U can also be written as gram. So there are 2 moles of K. So what is the 138? So let's see what the answer is. So 39 into 2, 39 into 2, that means K into 2 plus C. C is 12. Let's do this quickly. Most of you have already got the correct answer. Plus 12 plus 3 molecules of 3 moles of O, 16. So the answer is 138 grams. Yes, this is the answer. Okay, audio is not clear. Hello, can everyone hear me? Yes, Sanjay, it is 031. Yes, it is 138 gram. Okay, the answer is 138 gram. Can everyone hear me? Say if your audio is clear or not. I think the audio is clear. Okay, so Archisha, check your system. I think something might be wrong with it. So audio is clear, right? Type yes. Okay, so let's move forward. We are really lagging behind. We need to complete the class in 1 hour. Okay, so the next question. The valency of an element X is 1 and that of oxygen is 2. What will be the formula of the compound formed by the combination of element X with oxygen? Okay, so if you remember something from class 9, it is the cross multiplication system. Okay, so what we do here is that, let's say there are 2 elements, right? Element X and oxygen. So let's write the name X and oxygen, O2. Sorry, not O2, only O. We are taking atoms, not molecules. Okay, so O. Now it is stated that the valency of element X is 1 and the valency of oxygen is 2. Just cross multiply it and you get the answer. Okay, so the answer will be of their compound will be X2O. Okay, the answer will be X2O. So did everyone understand this? It was a really easy question. So if you have understood this, type yes again. Okay, we'll move forward. Yes, so if you have not understood this, just tell me, I'll explain it again. Okay, Bishadip, no, it's not H2O, it's X2O. The element is X. Okay, H2O is another compound. X2O is another. Here we don't know the X. Okay. Yes, it's X2O. Yes. Yes. So Lippi and Archisha and Vishwadeep got it right. Lippi also got it right. Yes. Okay. So let's move on to the next question. Okay. The valency of an element A is 1 and B is 2. Okay. Write the formula of the sulfate of A and the nitrate of B. Okay. So do you all remember the formula of the sulfates and the nitrates, the compounds? So let's just do the cross multiplication. There are two questions here, so let's divide it. So first let's take element A and element N sulfate. Okay, so the formula of sulfate is SO4 2. Okay, so 2 we are going to write here because 2 is the valency and the valency of A is 1. Okay, so if you don't remember this sulfates and nitrates and carbonates and every formula, so we have that. Okay, so I'll check in the link check in the description, it will be available. Okay, so I have made it available in the description, compounds list, so you can download it, you can print it, you can memorize it, it will be really useful for you. Okay, so SO4 2, let's just cross multiply it. So what will it be? A2SO4. No Sneha, it's not A2SO4 2, it is A2SO4 because the valency of element A is 1, right? So if we cross multiply it, A में तो 2 आ जाएगा तो A2 and then SO4 में तो 1 ही है तो SO4 ही रहेगा. So the correct answer is A2SO4. Okay, let's move on to the next question. So B, the valency of B is, yes, Sange is right, Bishadip is right, A2SO4. So the valency of B is 2 and the nitrate. Okay, so the formula of nitrate I am telling you right now, but when you go to write N.T.S.E you have to remember it. Okay, NO3 1, okay, sorry, only NO3. Okay, only NO3. So the formula of NO3, valency of NO3 is 1. Okay, so yes, Sange, Vishwadeep, Archisha, yes, all of you are right. Okay, answer is A2SO4. Okay, so let's move on. B, the valency of B is 2 and the valency of nitrate is 1. Okay, cross multiply it. So what will it be? B NO3. Now we cannot write here 2, that will be 32. Okay, just add in bracket, add a bracket and write here 2. Okay, so there are 2 moles of NO3 and there is just 1 mole of B. Okay, B2NO3. No, it's not B2NO3. Sneha, I don't think you have understood the concept really well. I am going to explain it again. Okay, so let's say there is a compound, let's take 2 compounds X and Y. Okay, X and Y. Okay, it's for your information, the answer is sulfate A2SO4 BNO32. Okay, BNO32. Okay, so let's understand this once again. There are two elements X and Y. The valency of X is 2 and the valency of Y is 2. Let's not take it 2, let's take it 4. Okay, valency of Y is 4. Let's just say valency Y is carbon. Okay, no, I mean it can be anything, we can assume it's carbon. Okay, so yes Lippi, you are right, and it is yes, Sneha also right now, BNO32. And no, it's not BSO4. We aren't trying to find the sulfate of B, we are trying to find the nitrate of B. Okay, BNO3 2. Okay, so we are trying to find the nitrate of B, not the sulfate. So I'll just explain it once. So we just have cross multiply it and simplify it. Okay, just cross multiply, nothing else. X4 y2. Now both of them are divisible by 2, so we can write it as x2y. Okay, so I hope all of you have understood this. It might be useful for you, and yes, every one of you is correct. It's BNO2. Okay, BNO32 and A2SO4. So we are moving forward. Okay, we are going to the mole concept, one of the most important topics you will study ever, because it's 9th, NTSE, 11th, 12th, NEET, JEE. So it's everywhere. Okay, if you are taking science in class 11th, then this is you cannot avoid this. Okay, you cannot avoid this. So yes, so let's start. What is mole, right? So mole is the link between the mass of atoms or molecules and the number of atoms or molecules. Okay, so here atoms and molecules can be interchanged. Their meanings are obviously different, but when we talk about mole concepts in this preliminary concept based formulas, we can exchange them. Okay, so the mole is the link between the mass of atoms and the number of atoms. Okay, so let's say it's something like this. So let's say there is 1 kg of sugar. Okay, we have 1 kg of sugar, so we can also write it as 1000 grams of sugar. Okay, 1000 grams of sugar. So here instead of kg it is mole. The short form of mole is MOL. Yes, it's probably MOL, I am not very sure, so let's just write mole, and here it is 1000, not 1000. Okay, this is just an hypothetical example. 1000 atoms. Okay, not 1000, but you get the view, right? So here, yes, so okay, yes, so 1 mole of atoms is 6.022 into 10 raised to the power 23 of atoms. Okay, so if someone says that O2, okay, so there is O2, how many moles of atoms are there? There are 2 moles of what? Oxygen. 2 moles of oxygen. Okay, 2 moles of oxygen. So how many atoms? 12.044 into 10 raised to the power 23 atoms. Okay, so I just made a mistake here, this won't be there. Okay, and there will be only 1 mole of atom. Okay, sorry for this, it will be 1 mole. Okay, it will be 1 mole of oxygen, and it will be this 6.022 into 10 raised to the power 23. Now 1 mole of molecule. Okay, 1 mole of molecule, here O2 will come. O2, 1 mole of O2, this is molecule, right? O2 is a molecule, so it will be 6.022 whatever this is, molecule, number of molecules. Here it was number of atoms, here it was number of atoms, now it is number of molecules. Okay, molecules. Here also the examples have been given. 1 mole of oxygen atoms, that means O is 6.022 into 10 raised to the power 23 number of oxygen atoms, and 1 mole of oxygen molecules, that means O2 is 6.022 into 10 raised to the power 23 oxygen molecules. Okay, see this, atoms, molecules. Now this 6.02 into 10 raised to the power 23 is recurring in each and every step, right? We have seen. So this is also known as the Avogadro's number. Okay, this is known as the Avogadro's number. So have you all understood all of this, whatever khichdi we have made? Have you understood? Type yes. This is a really important concept, so I'll wait for you to type yes, and if you haven't understood, I'll teach it again. Okay, no, there should be no doubts in this. Okay. Because this will be really useful for each and every competitive exam you are going to appear for, unless you have taken if you have taken science. Yes. Next we'll just do some questions and then it will be over. Okay, so I've also made a worksheet, link will be in the description. So yes, okay, so I'm just going to proceed. Yes, so I hope all of you have understood it. Next question. Okay, yes, how many moles are 5 grams of calcium? Okay, I'll just do this question for you. I mean, you can do this too, but just for clarity of concept, I'll do this. Okay, type in the answer. If you know the answer, type in. I'll say if you are wrong or right. Okay, so how many moles are 5 grams of calcium? Okay, so now do you remember the okay, so it's given atomic mass of calcium is 40 U. Okay, so we can write it as 1 mole. No, wait, there is a really simple formula for this. No need of all of this khichdi. Okay, yes, we can use this formula. Okay, note this formula, screenshot it, whatever you do, this formula should be in your hearts. Okay, number of moles of atoms is equal to mass of element by gram atomic mass of element. Okay, what does it mean? In the left side it is number of moles of atoms. Okay, so it can be 1 mole, 2 mole, whatever it is. So the number of moles of atom in the LHS, and in the RHS what it is, mass of element, how much mass is given to us, divided by gram atomic mass of element. What is the gram atomic mass of element? 40 gram. Okay, it is asking us in gram, so it's 40 gram. So now we have to find how many moles are there in 5 grams of calcium. So number of moles we have to find, right? We don't know this. What is the mass of element? 5 grams. How many, what mass of calcium is given to us? 5 grams, right? 5 divided by gram atomic mass of element. How much it is? 40 grams. 40. What is 5 divided by 40? 1, it will be 8. So 8, 1 by 8. So 1 by 8 is somewhat about 0.12 mole, right? It should be 0.12 moles. Yes, 0.125 moles. Okay, so the answer is 0.125 moles. So it could have been simplified. Okay, so have you all understood this? This question was really simple. There is some level of complexity in other questions, but this was a really simple question, just formula based. Okay, yes Lippy, you are correct, and Vishwadeep also correct. So yes, so have you all understood this? Type yes if you have. Our class has been going on for the next 50 minutes. Okay, so it will extend for some more 20 minutes I guess. 0.12 mole, 125 mole. Yes, everyone is correct. It is 0.125 mole. 1 by 8 can be, it ends. Okay, so it ends. So we'll move forward. I guess everyone has understood. Okay, so next, okay, I'll wait for you to do this. Okay, calculate the number of iron atoms in a piece of iron weighing 2.8 grams. Okay, atomic mass of iron is 56 U. Okay, really easy question this is. Okay, everyone of you have understood. Okay, number of iron atoms. Okay, so now we know mole is related to the number of atoms, right? Number of atoms. You all already knew this. I don't know why I am writing it. Okay, so Now let's apply the formula which, okay, number of moles is equal to mass of element by gram atomic mass of element. Here what is the gram atomic mass of iron? 56 gram. Okay, this is atomic mass. If we take the gram atomic mass, it will be 56 G. Okay, and you are expected to memorize the gram atomic mass of each and every, not each and every, but the important elements. Okay, because who knows, maybe they won't give the gram atomic mass, then how will you be able to answer the questions, right? Yeah, so let's start. So we are given 2.8 grams. Okay, so we are given 2.8 grams of iron. 2.8 divided by gram atomic mass. What is gram atomic mass? 56 grams. Okay, let's not write gram right now. So yes, 56. So that will be what? Number of moles, right? It will be number of moles. I hope you are, if you are, I hope you are getting what I am trying to say. Okay, it will be the number of moles. So when we divide it, we get, okay, let's divide it. 1.4, it will be 28. Okay, so yeah, 120. Okay, so it comes 1 by 20. Okay, it's 1 by 20. So 1 by 20 moles. Okay, so yes, Neha, you are correct. 3.011 into 10 raised to the power no, you are wrong. Okay, sorry. So yes, we will get back to it. So 1 by 20. So we know that this is the number of moles. Okay, moles. Now let's just create some space. Remember, 1 by 20 is the number of moles, and 1 by 20 is the number of moles. And Sange, you are wrong, it's not 12.44, and Vishadip, you are right, it's 3.11 into 10 raised to power 22. Okay, Sneha made a calculation error in exponents, which was really expected by her. So yeah, so try to not make silly calculation mistakes, and Lippy also correct. Okay, so we know that 1 by 20 mole. Okay, 1 by 20 mole is equal to, we know 1 mole is equal to 6.022 into 10 raised to the power 23. Okay, divided by 20, right? It is 20, so we can write it as 2 into 10. So let's cut it, it will be 22, and here we can cut it 3.011. Simple question. Answer will be 3.011 into 10 raised to the power 23. Okay, 3.011 into 10 raised to the power 23. Really simple question. Almost every one of you has done it, have done it. Sneha and Sange, this is the answer, and I think you have understood it. If you have not, comment section. Okay, we'll move on. I'll explain it to you again if you haven't understood it. So yes, okay, 22. Okay, I don't know what he wrote. Okay, so mass of 1 mole of cane sugar. Okay, so now here it is given the formula of cane sugar. It is C12H22O11. Okay, so now we have to find the mass of 1 mole of cane sugar. Okay, so now don't be confused by this 1 mole. We just need to know the gram atomic mass of each and every one of this element, like we did in the earlier problem. Okay, so C12. Okay, what is the gram atomic mass of C? Carbon C. So it is 12. Okay, 12 into 20, 12 into 12, 12 into 12, because there are 12 moles plus there are 22 moles of hydrogen, and gram atomic mass of hydrogen is 1. 1 into 22 plus 11 moles of oxygen, 16 into 11. Okay, 16 into 11. So the answer will be 12 square 144 plus 1 into 22, it will be 22, 16 into 11, 16, 16, 6, 7, 1, 176, it's 176, 176 is equal to 342 grams. Okay, just a simple problem of addition and multiplication. Okay, so your basic maths should be very strong. You should be able to complete this kind of questions in 10 seconds. Okay, so I think this is the last question of the class, and our class is just going to touch that 1 hour mark. So yeah, we are going on time. Okay, that's really good. So what is the number of water molecules contained in a drop of water weighing 0.06 gram? Okay, so now we know that the compound water, okay, nobody gave the answer. The previous question nobody gave the answer. You all understood this, right? So yes, if you haven't, just comment section. So what is the number of water molecules contained in a drop of water weighing 0.06 gram? Very easy. Number of moles is equal to mass given to us. Number of moles is equal to mass given to us. So mass by gram atomic mass. These are not the official short forms, these are something I have made. Okay, so we don't know the number of moles, we know the mass is 0.06 gram. Okay, now H2O formula, since you are in you will be in class 11th now, it's everyone knows H2O water formula, right? It's H2O. Okay, so 2 moles of hydrogen, 1 mole of oxygen, so it's 1 into 2, 2 moles, gram atomic mass of hydrogen 1 plus 16 gram atomic mass of oxygen, so it's 18 grams. Okay, so what we can say is that the gram atomic mass of the molecule is 18 grams. Okay, 18 grams. So now when we divide this by this, so the answer will come, okay, I haven't even written it, let's do it. Okay, so 9 0.02, okay, 2 900, what is this? Okay, let's try to solve it. Okay, so we take it to 900. Okay, I guess this is it. So 2 by 900 moles. Okay, so let's clear some space here. 1 mole is 6.022 into 10 raised to the power 23 molecules. Okay, so here 6.022, just try to bear with my handwriting, 6.022, and Bishwadeep and Archisha, yeah, you have given the answer at the exact same time and it's correct also, into 10 raised to the power 23 divided by into 2 divided by 9 into 10 square. Okay, try to write everything in squares. Okay, I mean in 10th place. Okay, so it's 10 square, so cut this and here it will be 21. Okay, so yeah, so this will be 3 3.2 points, sorry, I guess my maths is getting weak. 2.007. let's take the round off. Okay, let's take the round off. Okay, 2.007 into 10 raised to the power 21. So what about this and this? Did we make any mistake? Okay, let's go back to it again. Okay, I think I made some mistake. Okay, so we'll do it the other way. Okay, so I am going to teach you another way to do it. Okay, the more ways you know, the better, and this is just an excuse I am giving you all. Okay, so there are 18 we know that 18 grams, so 18 grams is 6.022. Yes, Archish, Sneha, Lippi, Vishwadip, all of you are right. Okay, 18 grams is equal to 6.022 into 10 raised to the power 23 moles. Okay, oh sorry, molecules. Okay, molecules. Yes, it's a very good question. Okay, so 6.022 into 10 raised to the power 23 number of molecules. So now we need 0.06 grams. Okay, so here what we have to do is 18 by 18 into 0.06, and we do the same thing with the RHS. Okay, so this is a clever technique which you all can apply. 6.022 into 10 raised to the power 23 divided by 18 into 0.06. Okay, so now what we did is that we had 18 grams, right, but we needed 0.06 gram. So how could we manipulate this equation such that we could get 0.06 grams? So what I did is that I divided by 18, so I would get 1 as my answer. So 18 by 18 1, and multiplied it by 0.06, the thing which we needed. Okay, so we got 0.06 grams is equal to 6.022 into 10 to the power 23, and here it is 18, right. So here also 18 into, we divided by 18, so 18 into 0.06. So finally after this the answer will be 2.007 into 10 raised to the power 21 molecules. Everyone has given answer to this question, so I'll just assume that you have understood this, and if you haven't, then type in the comment section. Okay, sorry for revealing the answer. So last question. Okay, after this we have some time. I'll just, no, nothing. Okay, this is the last question. If 1 gram of sulfur dioxide contains X molecules, what will be the number of molecules in 1 gram of methane? Okay, so we'll just go to the black screen. Just wait 1 second. Yes, okay, so we have 1 gram of sulfur dioxide. Okay, 1 gram of sulfur dioxide, and 1 gram of sulfur dioxide 1 gram of sulfur dioxide is equal to 1 x molecules. Okay, and so what will be 1 gram of methane equal to how many number of molecules? Okay, so let's this is somewhat long question, so let's go to the black screen. Okay, yes, black screen. Yes, okay, so now it is given that 1 gram of sulfur dioxide. What is sulfur? Formula of sulfur dioxide, SO2. Okay, formula of sulfur dioxide, SO2. So 1 gram of SO2 is equal to X molecules. Okay, we don't know how, X is just a variable. Okay, X number of molecules. So X molecules Is it visible to you all, this black screen? I hope it is. If it's not, again comment section. Okay. So 1 gram of SO2 is equal to X molecules. Now let's find 1 mole of SO2. What will be 1 mole of SO2? 1 mole of SO2, okay, SO2 is equal to gram atomic mass. Let's go direct to gram atomic mass. So what is the atomic mass of sulfur? It's 32 grams, okay, 32 grams. Please try to remember all of this. It is 32 grams, okay. So next we have 2 moles of oxygen. So 2 into 16, remember we did right earlier, moles of the gram atomic mass of oxygen is equal to 16. So 32 plus 16 into 16, it's 32 again. So 32 plus 32, 64 grams, right? So we found out 1 mole of SO2 is equal to 64 grams. Let's go in a systematic way, okay. So 1 mole of SO2 is 64 grams. So now we know that 1 gram of SO2 is X molecules, okay. Here it is 64 grams, right? So let's convert it into 1 gram. 64 by 64, it's 1 gram, right? So here it was 1 mole, so 1 by 64 moles, okay, 1 by 64 moles. Yes, 1 by 64 moles. Yes, so we found out that X is equal to 1 by 64 moles of SO2, okay. No, it's just 1 by 64 moles, nothing else. 1 mole is equal to 6.022 into 10 raised to the power 23. 1 by 64 mole we don't need to find, okay. So this is it. So now let's erase the upper part. Yes. So okay. So now we know that 1 by 64 moles is equal to X. Now let's find the mole of methane, okay. Methane, what's the formula of methane? It's CH4, okay, CH4. So 1 mole of CH4 contains 1 mole of C plus 4 mole of H, okay. 1 mole of C plus 4 moles of H. C, the gram atomic mass is 12, H, the gram atomic mass is 1. So the answer will be 12 plus 4, 16 grams, okay. Answer will be 16 grams. So now we need to find, if you remember the question correctly, we needed to find the what would be the how many molecules are there in 1 gram of methane, right? Number of molecules in 1 gram of CH4, okay. So yes, so number of 1 gram of CH4, how many molecules will be there, okay. So now here it is 16 gram, right? So let's write it in the terms of 1 gram. So let's continue it here. So it will be 16 by 16, right? 16 by 16 is equal to 1 by 16 moles, 1 by 16 moles, okay. So now we know that 1 gram of CH4, 1 gram of CH4 contains 1 by 16 moles of atoms, okay. It contains 1 by 16 moles of atoms. So what is 1 by 16 moles? 6.022 into 10 raised to the power 23 divided by 16. This much atom 1 gram of CH4 contains, okay. But we don't need to compute this. Why? Because it is already given that 1 by 16 mole, 1 by 64 moles is x. Okay, so let's try to find it in terms of x only. Okay, so now we know that 1 by 16 into 4, so you have to just apply some basic maths. Okay, 1 by so we know that no equal to, so let's erase the top part. Yes, okay, so now okay, you didn't understand. Okay, I'll explain it once again. It's a really long question, so it's hard to follow up, and we have got some time. Okay, so yes, I'll explain it again. So now that we have 1 grams of CH4, so we just need to apply some basic 1 by 64 moles into 4, 4 cut हो जाएगा, तो this will be 16. So we can say this 1 by 64, how much is 1 by 64 moles is equal to x, right? So x into 4, so okay, so nobody understood this. X into 4 is equal to, okay, so if you haven't understood this, let me do this all over again. Okay, let's do this all over again. And black screen. Okay, let's try to do this here. Okay, now let's follow with me. Okay, now sulfur dioxide, the formula is, sulfur dioxide formula is SO2. Yes, I am going to explain, I am explaining from the first, Sneha. Okay, so SO2. Okay, now methane is CH4. CH4 is methane. Okay, so first step we need to do, we need to find the gram atomic mass of both of these compounds. Okay, let's go with gram atomic mass of SO2. Okay, let's find the gram atomic mass of SO2. S, the gram atomic mass of S is 32. Okay, 32 plus gram atomic mass of oxygen, we already know it's 16 into 2. Why? Because there are 2 moles of oxygen. Okay, and only 1 mole of sulfur. So 32 plus 16 into 2 is 64 grams. Okay, 64 grams. So I hope you have understood till this part at least, and the other part also where we did it for CH4. So now let's just write the gram atomic mass of SO4 is 64 grams. It's 64 grams. Okay, now let's find the gram atomic mass of CH4. Gram atomic mass of CH4 is, we already found it, it was 16 grams. Okay, so I am not going to do it again. See, the mass of C is 12 plus 4 into 1, so that's 16 grams. Okay, so just keep in mind the gram atomic mass of CH4 is 16 grams. Okay, so now till this I hope every one of you are clear. Now what do we have to find? You have to find the number of molecules in 1 gram of methane. So 1 ग्राम of methane में, 1 ग्राम मीथेन में कितने molecules होंगे? How many molecules? Okay, molecules. So now let's and also one thing that is given to us is 1 gram of sulfur dioxide, 1 gram of SO2 is equal to X molecules. Okay. So now we know that 64 gram is equal to 1 mole. Okay. This is pretty clear to us. 64 gram is equal to 1 mole. Gram atomic mass of SO4. So SO4 in itself, the compound itself is 1 mole, and the gram atomic mass of this 1 mole is 64 gram. So now 64 grams of SO2 is equal to 1 mole. Okay. So 1 gram of SO2, how much it will be? 1 gram of SO2 will be, let's just keep it in bracket for better understanding. 1 gram of SO2 will be 1 by 64 mole. Okay, it's basic maths. 1 by 64 mole. So till this everyone is clear, right? So now we know that 1 gram of SO2 is 1 by 64 mole. So this is the only relevant information we found out of all of this. Okay, so this is the only thing we are going to write. So yeah, so 1 gram of SO2 is equal to 1 by 64 moles. Okay. Shit. Okay. 1 by 64 moles. Okay. So now similarly, let's find the what will be 1 gram of CH4, what will be 1 gram of methane. Now we are getting to the answer of the question. Okay, 1 gram of methane. Okay, so 16 grams, let's just keep it aside, 16 grams of methane, that means 16 grams of CH4 is equal to 1 mole. Okay, here also this is 1 mole, and this entirely, this compound is 1 mole. 1 mole means 6.022 into 10 raised to the power 24 molecules. So, and the weight of this one compound, not weight, mass of this one compound is 16 grams. Okay. So 16 grams of CH4 is equal to 1 mole. I hope you have understood the relationship, that how 16 gram got into 1 mole, how 64 gram got into 1 mole. Okay. So 64 grams of SO2 is 1 mole. Okay. 64 grams of CH4 cannot be 1 mole. 16 grams of CH4 is 1 mole. Okay. So 16 grams of CH4 is 1 mole. Again we do the same thing. 1 gram of CH4, 1 gram of CH4 is equal to 1 by 16 moles. Okay. Out of all of this, this is the relevant information which we found. 1 gram of CH4 is equal to 1 by 16 moles. Okay. So now let's write it. Okay. 1 gram of CH4 is equal to 1 by 16. Right. 1 by 16 moles. 1 gram of CH4 contains 1 by 16 moles. Okay. Now ethically you could directly find the number of molecules, because what is asked to us, 1 gram of methane is equal to, we need to find the number of molecules, right? So 1 gram of methane 1 by 16 moles. So we can just divide 6.022 into 10 raised to the power 23 by 16 and we would get the answer. Okay. But we aren't going to do that. Why? Because the relationship of X is given to us. Okay. So in NTSE, when obviously options will be there, so all the options will be in relation to the x. Okay, so like 4x, b 6x, something like this. Okay, so now let's find the relationship of 1 gram of methane to that of x. Okay, really simple, don't complicate yourself. I mean, just try to understand this with a clear head. Okay, so now these two are solid proofs. Okay, these two are solid proofs which we have got. Okay, so now okay, so we know that 1 gram of CH4 is equal to 1 by 16 moles. Okay, 1 by 16 moles. Now we can rewrite 1 by 16 moles in 1 by yes, 1 by 64 into 4 moles. Okay, so this is something which you will have to think of your own, the relationship between these two. This is you can find this, right? 16 into 4 is equal to 64. Okay, so now let's see, 1 gram of CH4 is equal to 1 by 16 moles. 1 by 16 moles is equal to 1 by 64 into 4 moles. Okay, so this 4 will get cancelled and this will be 1 by 16 only. Okay, so we changed nothing, we just multiplied it by 4 and divided it by 4 as well. Okay, so into 4. So now 1 by 64, what is 1 by 64? We already know that 1 by 64 moles is equal to x, right? It is given 1 gram of sulfur dioxide, 1 gram of sulfur dioxide, 1 by 64 moles. 1 by 64 moles is equal to x. 1 gram of sulfur dioxide contains x number of molecules. Okay, so 1 by 64 is x. Now we need to multiply x by 4. So the answer which we will get is 4x molecules. Okay, so everyone understood this, right? Type yes if you have understood this. Okay, so that's the end of this session. So in the description you will find 2 links. So one of the links is for the table for the sulfides and oxides and all the compounds. Okay, not every compound but all the compounds which were given in class 9th NCERT textbook, that will be there in the description. And then there is a worksheet made for you. So I hope you complete the worksheet. So yeah, so it's over. Thank you for the class. So download the worksheet, print it, solve it. Some of those questions have appeared in NTSE stage 1 and stage 2 as well. So yes, try to solve those. Okay, thank you. I am ending this stream. I hope you all have understood everything. Yes.